again, dear learners. You're welcome to GCL Tutorials, the best platform where social studies is taught the simple way, where you can understand this subject, become an excellent student in class, and also out there as the best social studies student. We've been looking at significance of some natural features of the Earth, and we have been taking a series of subtopics under this very long or lengthy topic. We'll be going deeper or further to look at something more. In this episode, we'll be looking at other types of mountains. The last video, I spoke about volcanic mountains, where we have magma in the outer core erupting on the surface of the Earth as lava. Then the lava solidifies to become rocks or form the mountains and take a shape. Okay. Now we'll look at other formations. We realize that not all mountains are formed as a result of volcanic eruption. There are some too that are formed as a result of the folding of the earth layers. As I spoke about tectonic movement or the plates, as the earth moves with pressure and heat, the layers of the earth bend or they collide. As they collide, they will definitely bend. Now, the collision causes the layers to either fold upwards or downwards. And when they fold upwards, you know we are on the crust, and the crust is the outermost part of the earth layers. So if we have human activities taking place on the crust, then definitely the layers down there or under the crust that fold upwards will affect the upper layer or the outermost layer and thereby show on its surface. Then you can have what we call fold mountain. So we'll get to the board and I will be sketching some diagrams. The diagrams will show you or let you know how this phenomenon occurs. It takes a long time for a fold mountain to form. With the eruption, when the place has active volcanoes, we are likely to see a lot of eruptions, volcanic eruptions taking place and forming those mountains. We have some mountain close to Mount Everest and other places. But with fold mountain, because it's a gradual process, as a collision takes place, the folding has to affect other parts. Some may not appear completely on the surface of the crust, but we know that with some, we can have them showing up and then elevating above sea level, so we can call them mountains. Now, let's look at what fold mountain. So I'll have two separate diagrams. Diagram A, which shows the normal layers when the collision hasn't taken place or the folding hasn't taken place. So these layers, I'm going to separate them or differentiate between them with symbols or signs or designs or shading or whatever. Anyhow, you can do same for yourself. So I have something like this. I'll have a layer here. So it shouldn't be too straight because the earth surface is not uniform in terms of being a plane. 1, 2, 3. Then you can have something like this. Now I decide to use this symbol to represent the fourth layer or this particular layer origin. Then I'll use this. Then I can have this as well. Then something happens to this layer. The force and pressure cause them to collide. The collision, they meet or come together and they begin to bend. They begin to bend. So this is showing the collision process. After the collision process, we're definitely going to have something like, so when it affects the innermost part or a lower layer, definitely it will affect the top one. So we will have something like this. The bending is taking place or the folding is taking place. That's it. 1, 2, 1, 2. Okay, so we can put this is showing that part of the layer that was folded up, the first one, then have this side too. Then this side or area too. Okay? Then you have the last one that has also undergone the folding or the bending. Good. So we have these parts folding up and these parts sinking within or folding downwards. So this is a crust or surface. We can have it here. So the normal nature or structure was like this, but when it went through the collision due to the heat and pressure and bent as a result of what I've just mentioned, the heat and the pressure, we now have a fold mounting. We now have a fold mounting. Okay. Some people can consider this part as a valley, though this has also folded upwards. So you can label it as such. This is still the crust surface of the earth. So it has undergone collision. Now, technically, geologists call the parts that fold downwards and sink. So those ones will show the interior part of the earth, they will show down there. So that part is called the sink line. All these ones folding down, these sides folding down, will become sink line. And the part that fold up, these parts of the layers that fold up will be called anticline. So I'm going to indicate one here. So you have a syncline and anticline. So this is a simple demonstration concerning the formation of a fold mountain. It's a gradual process. It takes so many years for us to see something like this occurring on the surface of the earth. So what then is a fold mountain? A fold mountain occurs or is formed due to the collision of the earth layers. Okay, as the earth layers move, they collide with each other. As they collide, they either bend upwards or downwards. You see, so the ones that bend upwards or fold upwards affect the upper layers, thereby causing the part of that crust to rise, okay, or raise itself above sea level. Therefore, we call that part the fold mountain. Then you add that the part that folds downwards is the syncline, and the part that folds upwards is the anticline. So anticline, then we have that as our fold mountain. So this is just a simple way you can explain this and avoid any form of confusion. We'll move to another topic, which for this particular episode, then end it there. The fault mountain. fault mountain. Fault actually brings a lot of bell or sound in your mind for you to understand that fault. Then we are going to talk about faulting, a break, something that has gone wrong within the layers of the earth. That is the fault one. So quickly, as we have this, I think we are okay with the fault mountain. Let's look at fault mountain, which is also known as fault block or block mountain. Okay, so without all the fault, as I've already stated, there is something that occurs. If you have an electric cable, so what I was just demonstrating with the fold mounting quickly, if we have the earth layers and the pressure causes the earth layers to bend, they will either fold upwards or downwards. So this is what I was trying to demonstrate. So the part here is the anticline. If it folds downward, and the part that folds upwards becomes the the part that folds upwards becomes the anticline, and the part that folds downwards becomes the syncline. Okay, so let's take note of that. But with the faulting, there is a break that occurs. So that same pressure and heat can cause the earth layers to undergo that break, or they tear apart or open apart or separate. As they separate, what is going to happen? There is going to be a fault in them. That is the break in them. That break can go deep and affect other layers and cause them to be weak. So the lower layers, if the lower layers become weak, definitely they will fall within or sink within. And because they are supporting the upper layers, as they fall within due to their weak nature, what is going to happen is that the top ones will also break or fall within, and that is going to lead to a block mountain, because the part that will be exposed or will be left standing on the crust, or as that part of the crust, will be called a fault or the block mountain. Let's quickly demonstrate that to see what we are talking about. So as usual, diagram A, I'm going to have my layers of the earth as usual. Okay, so this time around, then okay, so this is what I'm using. No more here, there's nothing, has nothing to do with collision. This one has to do with faulting or cracking of the earth layers, or breaking, cracking, faulting, breaking of the earth layers. So we are going to have something like this. As the break occurs, it can occur at any part. So let's take, for instance, the break occurs. So I'm using this to show the break. This is the crust. What is happening here is that as the break occurs within the layers of the earth, they get deeper depending on the intensity of that break, okay, or the degree or magnitude of the break or the crack. Alright, so we will have, if it doesn't affect any layer, the layer will still remain. So let's say it gets into some area around this place. Let's have this. Then a part where the break occurs. This part. Okay, so we have this, and then we have this. It is going to fall within, pushing this particular area down. So instead of it to come to this level, the crack has caused the weaker layers on the other side, this side and this side, to fall within. And as it falls within, it leaves the middle block standing and becomes an exposed standing block, becomes a standing block. So this becomes the block or fault mountain. So the crust, yes. Alright, so what we are seeing here is that something has occurred within the layers of the earth, and it is called faulting, the cracking. There's a fault, a break in the layers of the earth. The break affects the innermost part, because these parts are softer, okay, compared to the crust. The crust is the hardest part or layer. So what is going to happen? As these ones are affected, remember the top here is on this, meaning the lower layers are actually supporting the upper ones. Now, these layers have become weak due to the crack that occurred within. Let's use this demonstration. If a builder has erected a lot of steps, talking about, or levels of a building, okay, so maybe from the foundation level, it has two more or successive building, okay, or arrangement on it with the blocks or the bricks. Now, if they gradually take off the first one, the one that is the down, that is forming the first layer, if they remove some blocks from there, if they keep taking them out, what is going to happen is to create a hole or a space. Gradually, as that part becomes so weak due to the space or the break or the emptiness in that area, the topmost one that does not get support from the missing block will now fall within, okay, because they are no more there. So a break is causing the earth layers to open up or tear up, and as the separation occurs, any part of this can sink within. Now, eventually, if it happens that the side ones sink within due to the weak layers down here, then the middle one is going to be left standing. So any part that is left standing, okay, with fault mounting, any part of the crust that is left standing after the side crust or side ones have been dropped within or have fallen within due to the weak layers caused by the break in the fault or the cracking, then that part becomes the fault or the block mounting. So it becomes a block and it will be standing. The standing block then becomes the block mounting. That is what we are seeing over here. So we can have the design here as well. Still this, because this was part of the first layer that I used this particular design for. So this side has sunk within now, and then it has been. So this is the fault area, or the break that okay, So we now know this part of the fault mounting. This is a simple demonstration about fault mounting. Nothing difficult to understand. If you keep playing this video, you realize that I've already established folding. There is a collision of the earth layers, and that causes them to bend. Faulting, there's a crack within the earth layers causing a separation, thereby lowering some of the layers and leaving some exposed or standing on the crust. Mostly these mountains are not too high because sometimes the crack will not go deeper and only just lower the part or some part of the crust just for about few meters, okay, away from the normal level of the crust. Okay, so we have our block or fault mountain here. I believe these diagrams have been helpful, and this simple illustration has taught you a lot. You can now explain to people out there how fault mountains occur. We've looked at volcanic, we've seen the fold, and we've seen the fault ones. When it comes to the rest, like plateau and the dome, I was trying to explain. The dome is just a form of the volcanic mountain, but just that it does not appear. Okay, the lava, the magma trying to reach the surface, okay, does not appear because maybe this part was hard enough to suppress it, so it did not erupt, and thereby it's only ended up raising that part of the crust to take this round shape, like a semicircle or a dome. So that is a dome. So this becomes a dome mountain. Any mountain that has this structure becomes a dome mountain. But the direct opposite is a plateau. If it becomes a flat surface like this, yes, then we have a mountain with a flat top, then we call that a plateau. Mostly mountains with this flat top or this extension will have people settling on it. In Ghana here, we have the Kwewu Plateau. The Kwewu people are on the mountain. They find the Nkoko people down there in the valley. So that is a typical example. So this becomes a plateau, a highland or a mountain with a flat surface or top. So that summarizes for the two that we are left with. So it can actually satisfy our thirst or hunger in terms of trying to know what the 5 basic mountains are and how they are formed. Thank you for watching GCL tutorials. I'll be bringing you more lessons still under this lengthy topic. Keep watching GCL tutorials. Like, share, and make sure you tell a friend to also tell a friend to learn more and more. I'll see you again another time. Bye. Thank you for watching.